Hi guys, in this video we're going to have a look at solving simultaneous equations using substitution. So you might have already seen my video on simultaneous equations using elimination. This is a slightly different method for when we have an x squared and an x, so we can't actually eliminate these variables. Okay, so that's a bit of a key sort of way to look at this and go, this is going to be a substitution one. Also, what I'm going to do in this video is have a look at what it looks like visually to try and give you a little bit more understanding as to what's going on. So let's get cracking with the first example, which is this one here. So I've got y equals x squared plus 7x minus 2 and y equals 2x minus 8. Now, because they're both equal to y, I can actually set them equal to each other. So I'm going to have x squared plus 7x minus 2 equal to 2x minus 8. So I can do that because they're both equal to y, and therefore they're both equal to the same thing, and therefore they are equal to each other. Now what we need to do is to solve this. To solve it, you need to have it equal to 0. So I'm going to get rid of everything from this side and take it over to that side. So the first step is to minus 2x to both sides. So I'm using the balance method here. So I'm left with x squared plus 5x minus 2 equals minus 8. And I'm going to get rid of this to make it equal to 0 by doing the opposite. So add 8 to both sides, which leaves me with x squared plus 5x plus 6. And again, it equals 0. Once it's equal to 0, we can now solve this quadratic. So if it's a calculator, you'll use the formula. If it's non-calculator, you will factorize it. This particular question or example that I've picked here, I've deliberately picked it to be factorized. So if you haven't seen that video, make sure you do. Factorizing into double brackets, but that's what I'm now about to do. So I'm going to draw my grid. And I put in my x squared and my 6, and x times x gets me the x squared. I need some numbers that multiply to get 6, so I've got 1 and 6, 2 and 3, and which one of these can I use to get a 5? Well, I can actually use both of them. Now, some of you might be able to spot straight away which one to use, which is going to be the 2 and the 3, but if you're unsure, best thing to do is actually just to try both. So I'm going to draw another grid up here. X squared, which gives me my x, and plus 6. I'm deliberately going to use the wrong one here, just to show you why and how to spot it's wrong. So that gives me 6x, that gives me 1x. At the minute, if you simplify this, you get 7x. I want 5x. So I'm going to do minus x. So 6x minus x gets me the 5x, in which case if that's minus x, this needs to be a minus 1. And how you can spot that that's wrong is that 6 times minus 1 does not get you positive 6, it actually gets you minus 6. So that doesn't quite work. So that one is wrong, and as I said, it's going to be this one here where it's 3 and 2, which gives you 3x and 2x, and when you simplify it, you get 5x, and 2 times 3 is 6. So that's the one that we want. So I'm going to now go back to my question and put x plus 3 into brackets, x plus 2 into brackets, and that's equal to 0. So again, have a look at the video on solving quadratics via factorizing, if you're unsure of this next step. But what I want to do is make this bracket equal to 0. So if x is minus 3 plus 3 is 0, and then 0 times whatever's in this one will equal 0. And the same thing for this bracket. What does x need to be to make this bracket 0? Well, it needs to be minus 2. Okay, so minus 2 plus 2 gives me 0, and then 0 times whatever's in here equals 0. Now remember, with simultaneous equations, once you've worked out your x coordinates, you need to work out your y coordinates. So what I'm going to do is I'm going to take x equals minus 3, and I'm going to substitute it back into this equation here. It can go into either one, but this one's just a little bit easier. So y will equal 2 times minus 3, because x is minus 3, minus 8, which is minus 6, minus 8, which is minus 14. Okay, so when x is minus 3, y is 14. Same thing for this one. Put x equals minus 2 into there, so 2 times minus 2, then I've got my minus 8. 2 times minus 2 is minus 4, minus 8, which is minus 12. So when x is minus 2, y is minus 12. And you've solved it. Now, I said I'll have a look at what this looks like graphically. So you might remember, if you have a quadratic and you plot that, it's actually a curve. And you might remember this looks like a straight line, so y equals mx plus c. If you remember, that's the equation of a straight line. So this is a straight line and this is a curve. And if you plot that, it looks a little bit something like this, where here is our curve and this is a straight line. And what we've done is we've found these points here where they both meet, where they're both equal. Okay, so as you can see, we've got minus 2, and x is minus 2, y is minus 12, and this point here, x is minus 3, and y is minus 14, which is what we found here. So that's what it looks like graphically. Let's have a little look at this one then. So again, it's very, very similar. I've got my x squared here, so I'm not going to use my elimination. I'm going to substitute it. Now this equals y, so I can substitute this directly into that. So I'll have my x, and I will plus y, but y is equal to x squared minus 2, and then obviously the whole thing is equal to 9. So I've just substituted this in for y. I'm just going to rearrange this slightly, so I'm going to have my x squared first, then I'm going to have my x, then I'm going to have my minus 2, and then I'm going to have my equal to 9, because I want it to look like a quadratic, and I'm going to solve it, so it needs to equal 0. So I'm going to minus 9 from both sides, x squared plus x minus 11 equals 0. And like I said, when I was trying to solve this one over here, if it's non-calculator, you'll factorize it like I did there, or if it's calculator, you'll use the quadratic formula. So this one here I've deliberately picked to be the quadratic formula. So again, solving quadratics using the quadratic formula. Have a look at that video. But the formula is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And a is what's in front of the x squared. In this case, it would be 1. B is what's in front of the x, and again, in this case, it would be 1. And c is the number at the very end, which will be minus 11. And all I'm going to do is substitute that in. So minus, and then b, well, b is 1, so minus 1, plus or minus the square root of b squared. Well, b is 1, so 1 squared, minus 4 times a is 1, times c, which is minus 11, all divided by 2 times a, well, a is 1. So I'm just going to tidy that up a little bit. Minus 1, plus or minus the square root, well, 1 squared is just 1, take away, well, 4 times 1 is 1, times minus 11 gives me minus 44, so minus 44. Notice I left that take away there, and then when I did this, it was minus 44. All divided by 2 times 1, which is 2. And again, a little bit of tidying up. 1 minus minus 44. When you take away a negative, it turns into a positive. So it's the square root of 45. So I'm going to add them together, divided by 2. So let's work out our values. So this is a calculator job. So I'm going to do minus 1. I'm going to start with the plus this time, plus the square root of 45. And I want to divide that by 2. There we go, and press the SD button. That's going to give me 2.85 and some other bits and pieces. So in this question, it might ask you to round it to 1 decimal place, 2 decimal places. Either way, once you've worked out x, you now need to work out y. So I wouldn't get rid of this. I'd keep it all exactly the same and substitute it straight into here. So if x squared minus 2 equals y. So I've got this already. X is this, so I'm going to square it and take away 2 and press SD to get 6.145. I'm going to round this to 2 decimal places, so 6.15. Don't forget to get both answers though. So I had minus 1, this time I'm going to minus the square root of 45, and then divide by 2, and press the SD button, which is minus 3.85. I'm going to do 2 decimal places again, and just the same thing, substitute that into here. Again, I'm not going to get rid of this because this is a more accurate answer than my rounding, so I'm going to keep that exactly the same, and I'm going to square it, and take away 2, and that's going to equal y, which is 12.85. So again, if I have a look at what that looks like graphically, again, I'm going to have a curve and a straight line. So here we go. Here is our curve. There's the straight line of x plus y equals 9. And I found these two coordinates here. Okay, where we got the 2 point something. I can't remember what it was now. It was 2.85, 2.85, and 6.15. There we go, that's that one. And minus 3.85, so minus 3.85, which is going up there. And the 12.85 going across there. So that's what it looks like graphically, trying to find those 2 points that they intersect. Okay, so that's those two examples. Let's have a look at something slightly different. So, same idea of substitution, however, slightly different equations this time. So this time we have the equation of a circle, x squared plus y squared equals 17, and again I have a nice straight line. And I want to know where they intersect. I want to find those coordinates. So I'm going to do it algebraically, and I'll show you it graphically. So again, x plus 5 equals y, so I'm going to substitute this in for y. So I've got my x squared plus the y, which we know is x plus 5, and that was squared, and that's going to equal 17. Okay, so your first step is to expand this bracket, which I'm going to do to the side here. X plus 5, so x squared, 5x, 5 times 5 is 25. When I simplify these, I'm going to have 10x, and you can put it back into here. So I'm going to have x squared plus x squared plus my 10x plus the 25 equals 17. So a little bit of simplifying and rearranging now to get it equal to 0. Well, x squared plus x squared, there's two of them, so that's 2x squared plus 10x plus 25 equals 17. As I mentioned before, I need to make it equal to 0. So minus 17 to both sides. So 2x squared plus 10x, and that would be plus 8 equals 0. Now, you could factorise this, but I've already spotted that 2 will go into 2, 10, and 8. So I'm just going to divide everything by 2 to make this just a tad simpler. So that'll be x squared plus 5x plus 4 equal to 0. And again, you can solve this by factorising if it's non-calculator, or using the formula if it's calculator. I've picked this one to factorise. So non-calculator, so here's my grid, x squared and 4, and therefore x times x gets me my x squared. What numbers multiply to get 4? 1 times 4, 2 times 2. I'm after getting a 5. Which one do I use to get 5? I can only use that one. So 4 and 1, which is 4x, and x times 1 is x. If I then simplify this, I get 5x. Brilliant, I'm already there. No tweaking needed. So I have x plus 4 for one bracket, x plus 1 for the other bracket, and that's equal to 0. And just as before, I want to make this bracket 0, in which case x needs to be minus 4. I want to make this bracket 0, therefore x needs to be minus 1. Once you've got your values for x, we substitute it back in for here. Again, either one, but I'm going to pick this one because it's easier. So x plus 5, well, if x is minus 4, I do minus 4 plus 5. So y would be 1. And this one here, if x is minus 1, y would equal minus 1 plus 5. So y must be 4. So let's have a look what that looks like. So again, this was a circle. This was a straight line. So here we go. Here's a circle. There's a straight line going through it. And I've just worked out those coordinates there. Minus 4, 1. and minus 1, 4. Okay, so this is the points that they intersect, like so. Okie dokie. Let's have a look at this one over here. So again, I've got my circle, and again, I've got my straight line. So a little bit different here, because this one doesn't equal y, it doesn't equal x. So I'm just going to do a little bit of rearranging to make it equal either x or y. It's easier to plus 2y to both sides to make it all positive. So I have x equals 5 plus 2y. It's now equal to x, so I can substitute that in to that equation there. So I'm going to swap those round. 2y plus 5 in for x, because it's equal to x. It was squared plus y squared equals 5. So just like before, I'm going to expand this bracket. I'll do that over here. 2y plus 5, 2y plus 5. 2y times 2y is 4y squared. I'm going to have 10y, 10y, and 25. When I simplify that, I'm going to have 20y. So I'm going to put that all back in over here, which is 4y squared plus my 20y, plus my 25, and then plus my y squared there, and of course that equals 5. A little bit of simplifying, y squared plus 4y squared, that's 5y squared, plus 20y plus 25 equals 5. Again, I can't solve anything until it equals 0, so I need to minus 5 to both sides. So we're left with 5y squared plus 20y plus 25 equals 0. Again, you could just factorise this straight away, but I've noticed that 5 is a common factor, so 5, 20 and 25. So I'm going to divide everything by 5 just to make this a little bit easier, which is y squared plus 4y. Oh, hang on a minute, I haven't taken away 5, is it? That should be 20. Sorry, that should be 20. In which case, 20 divided by 5 is plus 4. And that will equal 0. Okay, so again, I need to factorise this formula, or quadratic formula if you've got a calculator, factorising if you don't. I deliberately left this as a non-calculator again. So I've got my y squared plus 4, y times y gets me my y squared. Numbers that multiply to get 4, well again I got 1 times 4, 2 times 2. This time I want to get 4y, so which one am I going to use? I'm going to have to use the 2 and the 2 to get the 4. So put those in, which is 2y, 2y. Quick check, does it work? 2y plus 2y is 4y. Yep, no messing about with negatives here. We're good to go. So that's y plus 2, y plus 2 equals 0. And of course, again, just like over before, I want to make these brackets equal to 0. So y will have to be minus 2, and exactly the same thing here, y will have to be minus 2. So actually it's the same. Once you've got the value for y, we substitute it back in to get the value for x. I'm going to put it into this one here. So x equals 5 plus 2 times y. We said y was minus 2. So x equals 5 plus 2 times minus 2 is minus 4. So 5 plus minus 4 is just 1. Okay? And of course, because these are the same, I've just got one coordinate here. X is 1, y is minus 2. So let's have a look what that looks like graphically. You might already be ahead of the game here. So just as before, I had my circle, and here's my straight line. And you might notice, in this particular case, there's only one solution because it just touches, well, it's a tangent to the circle. It just touches that one coordinate. So that's what's going on with that one. So if you just have one solution, that's what it looks like. And I've got one last example to show you guys, which is coming up here. And this one is just to show you, let's say, a particular thing that could happen. Again, I'm just going to substitute this directly straight in for y, because it's already equal to y. So I'm going to have x squared plus minus 2x plus 7 squared, and that's going to equal 3. I'm just going to expand that bracket very quickly. So minus 2x plus 7 minus 2x plus 7. Minus 2 times minus 2 is 4. X times x is x squared. That's going to give me minus 14x. That's also going to give me minus 14x. And that's going to give me 49. When I simplify this, I will have minus 28x. Putting that all back into here then, I have x squared plus 4x squared minus the 28x plus the 49 equals 3. Just as before, a little bit tidying up. X squared plus 4x squared gives me 5x squared. Just write the rest of it out. Needs to equal 0 before I can solve it, so I'm going to minus 3 to both sides, like so, which give me plus 46 equals 0. Nothing common to all them now, so I'm going to leave it like that. This one is a quadratic formula, so if you remember, minus b plus or minus the square root of b squared minus 4ac, all divided by 2a, where a is what's in front of the x squared, b is in what front of the x, and c is the number at the back. So all I'm going to do is substitute those values in. I always write the minus first, and b in this case is minus 28, so notice I've got that double negative there. Plus or minus the square root of b squared, well that's minus 28 squared, minus 4 times a, well a is 5, and c is 46, so times 46. That's all going to be divided by 2 times a, and a was 5. So a little bit of tidying up. So we did this deliberately, so minus and a minus, I'm taking away a negative, so that turns to a positive. So that's 28 plus or minus the square root, or minus 28 squared, that's minus 28 times minus 28. A minus times a minus is a positive, and that should come out at 784. Then I've got my minus 4 times 5 times 46, that should come out at 920, divided by 2 times 5, which is 10. A little bit of tidying up underneath the square root. 28 plus or minus the square root, and that will give you minus 136, all divided by 10. Now you might be thinking, what's going on here? And you'd be right to think what's going on here, because if you put that into the calculator, whether you plus or minus the square root, it's going to error, because you cannot square root a negative number, okay? Which means there is no solution to this example. Why? Well, if we look at it graphically, here's the circle. If I plot the straight line, it's there. There's no solution because it doesn't intersect at any point. So it's just a little heads up at what could also happen. It shouldn't come up in an exam, but it was just to be thorough and show you what happens when you have two solutions. When the line goes through, you have 2 points where it intersects. If it touches at one, and if it doesn't touch at all. Okay, so hopefully that illustrates how to substitute or solve simultaneous equations using substitution, and also give you a little bit of background as to what it means graphically. Thanks for watching, guys. Cheers.